Hey everyone, welcome to part 10 of Wolves on the BackBit, and don't worry, my paws are clean. Anyway, we are now 28 days into the project here, and I am starting to look for ways to save some cycles because my 6 frames per second goal is becoming uh, hard to achieve, and I'm realizing this now. And so, yeah, so the first place I look is the D800 area. The bitmaps don't seem to fully utilize what they have, so I'm going to try to take advantage of that. So, in the next couple days here, I do a few experiments. Learning mostly, and down the road, I do implement something based on what I learned in these clips that you are about to watch here. So it at least proved fruitful, and that's a good thing because, unlike my jitter reduction, it wasn't a complete waste of time. And this actually has further promise down the road. I like just the general gist of what I was up to. I don't know. Compression can be fun sometimes. Well, I guess you'll see. Anyway, let's get to it. Part 10, Color Nibbles. Let's watch. Okay, here's something odd I discovered. Um, this is one of the color buffers for one of the frames. Now, it's meant for the color RAM. So the koala converter is what did this, what made these values. However, you can see that some of the high nibbles are filled in. Why? Now, my only guess is it was used to keep track of something during conversion, and they understood it was just going to be discarded anyway, right? So now here's where it gets neat. Now, I put my own, this is my own padding I added, so it fills up a page. Coincidentally, I added the frame number here, which might actually be useful for detecting the end of the file. And this here is the other of the two buffers I'm running. It too has some high nibbles and mostly low nibble ones, right? Now, here's what I did. I wrote just a quick and dirty program, and this is it. It's pretty simple, and all it's doing is turning those into screen codes and coloring them and stripping out that high nibble at the same time. Now check this out. Can you make out a wolf? There he is. But anyway, look at the differences here. Now, this is an idea. I don't know if I'm going to chase it because it's probably a lot of work. But if I only encode like a Y offset and the value to put, Y offset, value to put, Y offset, value to put, based on what was already in the color RAM, a lot fewer color RAM writes need to occur. Does that make sense? If only the changes from the previous frame need to be done, the color RAM can be reduced, I don't know, it could be reduced none if every single byte is different, but it could be reduced quite a bit. In terms of data, yes, but in terms of processing time, unsure. Although, you can imagine, like if you're jumping from here to all the way to here, that's a big jump, because otherwise this is like 9 cycles, 9, 9, 9, 9, 9, 9, 9. That adds up, right? But is it worth it? A big pain in the butt. Down the road, if you wanted to, if you were really trying to squeeze the absolute most, this might be something worth pursuing. At the moment, though, I don't have my papers with me, it's in the car. I just plan on having most of the frames go straight to the D800 area, except for one on our way out. When we go to fetch the audio, we're going to buffer just one color page, like one frame's worth of color, in case the frame wants to update while we're gone. But yeah, I just had to see this. It's like, what? Kind of cool. Okay, that was 3 minutes. Oh, I'm sorry, guys. Now, I'm starting to dabble with this tonight. For some reason, the audio sounds wrong, and I can't make it sound right. Did I fry my SID chip? It has way more hiss than usual.
Oh, the water always tastes so good here.
So what I did is I went from version 8 down to version 7, and it still sounds bad. What's going on? So what I'm going to do, reload everything and hope for the best. Alright, yeah, I'll be back. Alright, you ready to be disappointed? Oh boy, I sure hope this works. It sounds clean again. I have no idea what happened that time, but I'm glad it's fixed. Now, unlike the color RAM, the video matrix is low byte or low nibble and high nibble together, and it really is in a busy place. So here's 2 frames back and forth. I don't think much can be compressed from one frame to another, and the problem now is, unlike the color RAM, which is one buffer essentially, I can only change based on the frame that was there in the previous buffer. Now, if I'm using 4 different buffers, the difference is comparing to 4 frames ago, and that's with no dropped frames ever, because the next frame is in a different buffer altogether, so this would not apply. Even if it was identical, I could not just go, yay, and save all those bytes. No, I could not. But it's mesmerizing. I wonder what the bitmap can do. There might be some savings there too. Theoretically, who knows? Maybe, like I'm pretty sure I can pull off 6 frames a second once I get this done. But with the bitmap, if the bitmap was able to save a lot of bytes, 6 frames could become 8. And of course, I don't even have it rendered for 8. I don't have the frames. I didn't make them, but I could recreate them if I wanted to. But as it is, this is a lot of work. And dealing with the BBT data in a raw style is going to be a pain in the butt as well. Just for fun, here is just the color RAM. Sure, a lot of zeros in this. I can probably take advantage of it, except for maybe there. We're almost at the end of the file. You'll know when the audio stream gets encountered. It's pretty close here. Two, one. Yeah, can you tell? Oh, and now the audio is done too. BackBit will keep reading zeros until it wraps around completely. Okay, this looks very familiar. This time round, it's actually keeping track how many deviations to the last frame there's been. It's just a little rough and whatever sort of method. Anyway, I'll show you when this is done and show you the counts. Okay, the file played through. Now it's converting, oh, well, it's already done it. Basically, here's a bar graph, nice and rough and basic. How much of the color is different from frame to frame. As you can tell, most of it changes very little. But whether that's interspersed with same, different, that would take a long time anyway. But a lot of these frames are, you know, good savings to be had, except there. Ooh, that's costly. That's not cool. Here, I'm just slowing down the action because I just want to study this. It might be easier just to encode the ones that are zeros. Now here's that part where it flickers from blue to black or whatever. I don't like that, but that's the koala conversion. If I can find a way just to squish all these little black @ symbols into a repeated stream, it might be able to render the color faster with minimal work on my part. This time around I had it count how many zeros are in the file, in each color frame. Here we go. Like that first part at the beginning, that's underwater. It's mostly the black. But there's a lot of zeros here, whether they're scattered. You know, it's not looking for ones in a row, unfortunately. But there are a lot of them. This time it's just a rough way of counting 4 in a row of the zeros. Unfortunately, if there's like a sequence of 8, it's going to count it 4 different times. This time around, there, a dot indicates new information is needed. A solid square means that did not change since last time. So only the dots need to be updated. Added a little pause so I can hold it down. Even though this looks very busy, once again, only the dotted areas need to be updated. So maybe a run length encoding of just zeros isn't good enough. This is the data I need to compress. If I can get this down into something that's a buffer size and throw it back at the D800 area on the fly quickly. Ooh, look at that one. Yeah, these are the frames at the beginning that flicker. Once those are done with, though, it's a little easier. Still not sure if this is worth going ahead with. All right, now everything that doesn't need to be changed is a simple solid black. All right, this time around I added this whittle routine, so if it sees like a repeated thing from the last buffer by itself, it'll just go screw it and just add to the continuous stream that we need to replace. But if there's 2 or more, it'll leave them alone. So you can see them quickly flickering as the whittle routine checks them over. So now I'm going to add this for 2, possibly 3, you know, until it starts paying dividends to actually jump over a few. Okay, this time I added a little bit of delay between the whittle of the singles and the whittle of the doubles. Check it out. So it's turning what might be complicated and slow to re-render into groups of more satisfying things. Now that's just getting rid of isolated groups of 1 and 2. I don't know if I should add it for 3, but this is just a look over. I'm not changing the data at all at this point. I'm just wondering at what point should I dive in and start altering the BBT, because as soon as I screw it up, I have to switch out the memory card, put it back in the computer, replace the BBT that I've corrupted, and start again. So the testing cycle is a little quicker, or well, a lot slower than just rebooting the machine. I'll just hold it down now.